So now we're going to look at example 3, which is solving this quadratic by graphing. Now the first thing we have to find is where it crosses the x-axis again. So what we're going to do is I'm going to take this quadratic and find its roots, okay, where it crosses the x-axis. Now this one's a little bit more difficult. It's not an easily factored one. So what we're going to do is I'm going to use my favorite method of solving these, which is the quadratic formula. Remember, that's negative b plus or minus square root of b squared minus 4ac all over 2a. Okay? And so I put my numbers in where they belong. So b is 4, a is 2, and c is negative 5. So I get negative 4 plus or minus the square root of 4 squared minus 4 times 2 times negative 5 all over 2 times 2. Okay? So I put this into my calculator, simplify it just a little bit, plus or minus square root of, let's see, 16 minus 4 times 2 is 8 times negative 5 is negative 40. So really this is plus 40 and then over 4. Okay, so I can put this in my calculator, and when I do that I get negative 4 plus the square root of 56 divided by 4, and I get x to be 0.87 approximately, and then I do negative 4 minus square root of 56 divided by 4, and then that's the x equals negative 2.87. Okay, so those are my approximate values of x that I have as my roots. Okay, now since I know that those are there, okay, I can kind of graph those. So like a little bit smaller than 1, okay, and then the other one is just pretty close to negative 3 right there. Right? Now, if I'm looking for where my vertex is, right, to figure out my parabola, okay, what I'm going to do is I'm going to say, okay, well, b is 4, so it'd be negative b over 2a. So in our case, it would be negative 4 over 2 times 2. So that ends up being negative 4 over 4, which is negative 1. So x is equal to negative 1 at my vertex. Then I put negative 1 into my equation right here. Okay, so 2 times negative 1 squared is 2, plus negative 4 would be negative 2, minus 5 would be the point negative 1, negative 7. Okay, so if I go over here, negative 1, negative 7, right here. So you'll see where my vertex is. You see where it crosses the x-axis. Okay, and so I'm going to go right in here, go right in here, right? And solid line because it's greater than or equal to 0. Okay, so here's my parabola. Now I got to figure out, do I shade inside or outside? Okay, and then I can figure out how I'm going to label my answer. Well, so what I'm going to do is I'm going to try the point 0, 0 back in my original equation. Okay, so I put 0 in. That goes away to 0. That goes away to 0. I get negative 5 is greater than or equal to 0, which is not true. So that means that everything around my parabola is actually the bounded region. And so then my solution set is going to be x is less than or equal to negative 2.87, and x is greater than or equal to 0.87. So my solution set is both of those. Okay, less than negative 2.7 and also greater than 0.87. Here's a couple guided practice problems that you can try. We'll try letter B. So how we're going to solve this, again, I think the easiest is using the quadratic formula. So our B is 5, A is negative 4, and C is 7. So I put it into the quadratic formula. I get negative 5 plus or minus square root of 5 squared minus 4 times negative 4 times 7 all over 2 times negative 4. Okay? Simplify it just a little bit more and get negative 5 plus or minus the square root of 25, and then 4 times negative 4 times 7 would be negative 112, so we'll be adding 112 all over negative 8. And so I can put that into my calculator. Now I get negative 5 plus the square root of 25 plus 112 all over negative 8. And so I get x equals negative 0.84. And now I'll do negative 5 minus the square root of 25 plus 112 divided by negative 8. Negative x equals positive 2.09. So those are my two solutions. So now what I'm going to do is I'm going to graph it, okay? And I know yours doesn't have a graph, but I can make one real quick. Okay? Like this, right? And so negative 0.84 is like right there. 2.90 is like right there. Okay, got to figure out my vertex. Okay, so in this case, it's going to be negative 5 over 2 times negative 4. That's just going to be negative 5 over negative 8. So 5/8. Okay, so it's going to be like right around there. And then I put that value into my graph, or into my quadratic. So negative 4 times 5/8 squared plus 5 times 5/8 plus 7. And so that's 8.5625. So that's going to be like up here. And so then it's going down, okay, down here, right? And so then I try 0, 0 because it's inside. So 0, 0, and I get 7 is greater than or equal to 0. That means I shade within it. Now, because I shade within it, means my solution set is within these points right here. So that means that my solution set is going to be negative 0.84 is less than or equal to x, which is less than or equal to 2.09. Here's my solution set right there. Here's a real world example. It says, refer to the beginning of the lesson. At what time will the water balloon be within 3 meters of the ground after it has been launched? So, essentially, the equation that they give us that's earlier in the book, which you don't have in front of you, is this. The height, according to time t, is equal to negative 4.9 t squared plus 32t plus 1.2. Okay, so that's my equation of my water balloon. Okay, it says at what time will the balloon be within 3 meters of the ground after it has been launched? So we want our height now to be equal to 3. So I'm going to rewrite it as 3 is equal to negative 4.9 t squared plus 32t plus 1.2. Okay, so a couple different ways I could solve this, right? And I'd say probably the easiest is going to be to subtract 3 from both sides. Then this will be equal to 0 because we can't put it in the quadratic equation until it's equal to 0. So that's what I'm going to do. Alright, I'm going to say 0 is equal to 4.9 t squared plus 32t minus 1.8. Okay? Now those are numbers I just put into my quadratic equation. We've done this enough that you know it's going to be negative 32 plus or minus square root of 32 squared minus 4 times 4.9 times negative 1.8 all over 2 times negative 4.8. Right? And so I put those into my calculator. I figure those out just a little bit easier, and I get two answers. Okay? I get x is equal to 0.06, and I get x is equal to 6.47 seconds. Okay? Those are both in time. Right? So the question is, okay, if I go back to the original question, at what time will the water balloon be within 3 meters of the ground after it has been launched? So there's 2 times, okay, after it gets launched, right away at 0.06 seconds, and then it's going to go up to its max height and then come back down in approximately 6.47 seconds. Okay? So it'll be within 0 both of those times. Here's a guided practice problem number 4 that you could try as well. Now, I'm not going to talk about this. You know how to put it in Okay, so 0 or 100 would actually be your height. So then you end up getting 0 is equal to negative 16t squared plus 82t. And then it would be subtracting it, so it'd be minus 99.75. And then once you put that into your quadratic equation, I won't show you how to do that because you know how to do it. You end up getting t is equal to 1.99 seconds, and you get t is equal to 3.14 seconds. So between those two times are when the rocket is at least, meaning more than 100 feet above the ground. Now finally, example 5 is to solve a quadratic inequality algebraically. Okay? So to do that, okay, what I'm going to do is I'm just going to assume that it's equal to 18 instead of less than or equal to 18. And then I'll test all my different cases. Okay? So if I'm going to do this a couple different ways I could, I'd say the easiest is to subtract 18 right here. And then we can put it into our quadratic equation. We get x squared minus 3x minus 18 is equal to 0. Put it into our quadratic equation, right? And so we'd get 3 plus or minus square root of negative 3 squared minus 4 times 1 times negative 18 all over 2. Okay, so then that's really 3 plus or minus the square root of 9, and then plus 4 times 1 times 18 is going to be 72 all over 2. And so this is a little bit easier. Put in our quadratic equation. We get x equals, I put this in, I get 3 plus the square root of 9 plus 72 is 81, divided by 2, so I get 6, and x equals 3 minus the square root of 81 all over 2, negative 3. So my two solutions I get are 6 and negative 3. And now what we have to do is test to see where it works. So let's think of a number, okay? I go back to this original equation, and I'm going to think of a number, okay? I got three cases, essentially, I guess. Let me say it this way. Okay, I have three cases. Either x is less than or equal to negative 3, either negative x is between negative 3 and 6, or x is greater than or equal to 6, okay? So it's either these two together or this one together. Those are my essential options, okay? So let's try a number that's less than negative 3. Let's say negative 10. I put negative 10 in for x. Negative 10 squared minus 3 times negative 10. And it should be less than or equal to 18. So this would be 100 plus 3 times 10 would be 30. So 130 is less than or equal to 18. Now is 130 less than or equal to 18? It is not, so that doesn't work. Now the next one. Okay, I try the next one. A number between negative 3 and 6, well, that's 0. So let's try. 0 squared minus 3 times 0 is less than or equal to 18. Well, 0 minus 0 is 0, is less than or equal to 18. And so that works. That's good. Okay, so I give that a check mark. And let's try the last one. See if that one works. Okay, pick a value of x that's greater than 6. Well, let's try positive 10. So we do 10 squared minus 3 times 10 is less than or equal to 18. Well, 10 times itself is 100, minus 30 would be 70, is less than or equal to 18, which again is not true. So the true solution set is this one right here. My answer is negative 3 is less than or equal to x, which is less than or equal to 8. Excuse me, 6. Here's a guided practice problem. You can try letter B. So what we're going to do is we think of the two numbers that multiply to 30 and add up to 11. That would be 5 and 6. Okay, so we end up getting x squared plus 5x plus 6x plus 30, 0, right? And so we take an x out, x plus 5. Okay, we take a 6 out, x plus 5. Okay, equals 0. So then we get x plus 6 equals, or x plus 5 equals 0. Okay, so then when we solve each one independently, we find that x equals negative 6 and x equals negative 5. And we can try our three different cases. What we end up finding then is that x is less than or equal to negative 6 and x is greater than or equal to 5. Excuse me, negative 5.